So we are ready for Chapter 2, Lesson 2. We have successfully learned about how to change a fraction into a decimal and how to change a decimal into a fraction. We talked about having to have common denominators in our fraction. We're going to do the exact same math on Lesson 2. This time we're going to add an extra step. So sometimes it's just going to be basically comparing two fractions or a fraction and a decimal. Sometimes it's going to be putting in order from least to greatest, or they may try to trick you and put it in order from greatest to least. We have to make sure we read the directions. The extra step is making sure that we know what comparing means. Now, we talked about this in Chapter 1. Now, in Chapter 1, we talked about how I know other teachers might teach it a different way. I always try to teach things the easiest way for people to remember. So if I know that these are arrows, the arrow is always going to point to the smallest number. The point is the tip of the arrow. So I know, since this is pointing this way, this is going to be the smallest number. And since this is pointing this way, this is going to be the smallest number. If we can remember that, then usually the next type of problems are much easier. All right, so when I go into our book, then this is where, that's the cue. Mr. Barker wants me to be following along, paying attention. My pencil needs to be in hand. He's going to show me exactly how to do these problems, explain it to me, and show me the steps that I need to do in order to get all the points on my homework assignment. So when we look at the first story they're telling about, so they're talking about dogwood trees that have been planted, and they want us to put the heights of the trees in order from least to greatest. So when I look at my numbers, I have three different ones. I check my work to make sure that it is indeed least to greatest, and that is what my book says right here, least to greatest. So I'm going to have 6 1/2, 5 2/3, 5 5/8. Now something ought to jump out in your mind about putting things in order from least to greatest. You ought to be able to look at that and say, I know which one is the greatest one. That down below is where they are starting for you in the work section. So they say compare the whole numbers first. And when I see 6, notice they put it in blue and 1/2, 5 2/3, 5 5/8. Well, they have a comparison of the whole numbers of 5 and 6, and the arrow should be pointing to the smallest number. Because the smallest number is 5, that tells me 6 is the greatest. I know that that automatically is going to be my last answer. Notice down here where they're putting the numbers in order from least to greatest, they've already showed you that has to be the largest number. The 6 is definitely larger than 5. But then that leaves me now with two numbers that I have to compare that both have a whole number of 5. So now I have to look at the fractions, and I do not have the same denominator. So we talked about before, if I have fractions, I have to have the same denominator in order to be able to work with them. So on my same denominators then, this is a key concept. Having common denominators, the same denominator, we're going to be using several times throughout the year from this point forward. So if I'm comparing fractions, have to have the same denominator. If I'm adding fractions, same denominator. Subtracting fractions, same denominator. So that's going to be a key point from this point forward throughout the year. Well, what does that mean and how does that work? Well, when I look at it, then we talked about before as the opposite denominators. So that's really what they're setting up there for you, and they've got a couple of them filled in, but let's look exactly as to what they're trying to show me. When I look at the opposite denominators of what we're talking about, so my original numbers was 5 2/3, so I'd be talking about the 3. And my second one was 5 5/8, so I'd be talking about that 8. So these numbers come from the concept, well, if this is a 3 in my denominator, then I'm going to carry that over to my next mixed number, and I'm going to multiply top and bottom. So remember what we said before. If I do something at the bottom of a fraction, I have to do the same thing at the top. If I multiply by 3 at the bottom, I have to multiply by 3 at the top. If I know about numbers and what fractions are telling me, 3 over 3 has a value of 1 because 3 divided by 3 is 1. So it doesn't change the value of my mixed number that I'm working with. It just changes the digits that's in the numerator and denominator. Not changing the value is key, and that's why we multiply by a form of 1, which is the 3 over 3. Then I have to look at the denominator on the right and move it over to the left, multiplying by opposite denominators. So I know I'm going to do an 8, which is what they've done here. This is a form of 1 because 8 over 8, 8 divided by 8 is 1. It will not change the value of my mixed number. It does change the digits that are in my numerator and denominator. Not changing the value is key, and that's why when I multiply my denominator by 8, I have to multiply my numerator by 8. So when I set those up, then I can just simply do the math to find out what my new mixed numbers are. So I just simply multiply across 2 times 8 and 3 times 8. Well, 2 times 8 is 16 and 3 times 8 is 24. So what we're going for is to have a common denominator or the same denominator. That's what common means. So I should see that work on the next one. 8 times 3 and 5 times 3 gives me indeed a common denominator of 24. So if I have a common denominator of 24, then all I have to do is rely on the numerators now, since the whole numbers are the same. The numerators then, I have to know which one's the smallest and which one's the biggest. So look at what these symbols are telling me. The symbols are telling me that whatever is to the left of 6 1/2 is smaller. But then I also know to the left of that number has to be another smaller number. So when I set them up, I have 16/24, and I have already written down the 6 1/2. So the 16/24 is indeed larger than the 15/24. So I know this one has to be my middle number. Now I can't write it down that way because that's not the number that I was originally given. I have to write my original form down. So this is going to be the 5/23 because the 16, it is smaller than 6 1/2, but it's still greater than, because it's on the right of this sign, it's still greater than this number. And the only number I'm left with is the 15/24 because 15 is smaller than 16. But once again, I have to write it in its original form. So I have 5 5/8. So when I see what order they're supposed to go in, I can tell that I am correct because I know the arrow points to the smallest number. 5 5/8, the 15, is indeed smaller than the 5 2/3, the 16, and we know both 5s are indeed smaller than the 6. So I know they're in the right order, so then I just fill in my answer spots. My smallest would be 5 5/8, followed by my 5 2/3, and then my largest one is 6 1/2. So that's one example of what we're going to be working with. Now, this is another example. So we're really supposed to compare 92 hundredths, which is 0.92, and 2/7, the 2/7. But they said, well, if we think about it a little differently, because once again, there's more than one way to do a math problem, right? So if I think about it a little differently, and I just use 1/2 to compare both of them to, then I should know what the relationship is between the two answers or the two numbers that I'm given. So it tells me, so compare the 92 hundredths and the 2/7. So I'm going to compare first them each to 1/2. And then that should show me the relationship of each other. All right, so when we do fractions and decimals, which way is easiest? And there's always more than one way, but I truly believe that when I have fractions, that just dividing them is the easiest way to do it. Once again, I take the fraction and the numerator is going to be divided by the denominator. So my numerator, my top number, is my dividend. And my bottom number, my denominator, is my divisor. Once again, some of you are not in the realm of thinking about decimals yet, and you're going to be saying, wait, that's a small number divided by a big number. I can't do that. I need to switch those around. Never switch them around. The top number, it has nothing to do about size. The top number always has to go inside my division box because it is always my dividend. Don't think about size, think about just how I'm going to create a number. Because this lesson is all about fractions and decimals, so that will allow me to have a decimal. So I add my decimal behind the 1, I raise it up, and put it in the direct place, location. I never shift over. I had a couple of you shifting over on your math test on a division of a decimal by a whole number question. The only time I shift my decimal is if this is a decimal on the outside, which is not what this lesson is about. So I bring my decimal up and I add a 0. That's going to let me divide. 2 will go into 10 5 times, and that's my simple answer. So what I have is 0.5 and 92. So, well, 5 is smaller than 92. And that is a true statement, and it will apply to this question, but it won't always apply, and we'll see that here in a few minutes. So one of the things I have to make sure that I do when I'm comparing decimals is I have to look at my decimal spaces that I have and make sure that they both have the same number of decimal spaces. Okay? The reason I say that is if this was a 17 here, 0.17, which it's not, but let's say it was, we would say, well, 5 is less than 17. But that's not a true comparison because it's decimals. So when I make sure that this has 2 decimals and this has 2 decimals, then what I see is this is a 50. If this was 17, then this would be the smallest number. Now in this situation, it is a 92 and it is a 50 that I'm actually comparing. So the idea that we first would have that that's a smaller number is still correct. But I have to prove it and make sure that I have the same number of decimal spaces. So I just add that 0 just to make sure that our initial thought is correct. So our arrow is going to point to the 1/2 because we're showing it is indeed smaller. 50 is smaller than 92. When I do my fractions, I could make them with common denominators on the 2/7 and the 1/2, but once again, I really think it's easier to divide. But let's just look at what happens when I do the common denominators. How do I find a common denominator, or the same number at the bottom? Well, that's when I'm going to multiply by my opposite denominators. So I see a 7 here, which tells me I have to multiply both numbers on the other side by 7s. And then I see a 2, and do the same thing with the 2. So when I multiply both by 7s, once again, that doesn't change the value of 1/2. It just changes the digits that I'm using to show the value of 1/2. Because I'm doing both top and bottom by 7. Then I know this side is a 2, so I have to multiply the opposite side by 2's, not changing the value because I'm doing both top and bottom by the same number. When I do that and I do the multiplication, then I can see that 2 times 2 is 4 and 2 times 7 is 14, showing what we're doing is getting a common denominator to compare. Well, 2 times 7, that is indeed 14. So that works for me, and 1 times 7 is 7. Now I have numerators that are different that I can compare. 4 is indeed smaller than 7, so I know that 2/7 has to be smaller in value than the 1/2. Now if you would have just divided those, I do believe that it would have been easier, but this is what we learned. We learned that 92 hundredths is greater than 2/7. Well, how do I get that? Well, if I know that 2/7 is smaller than 1/2, and I know the 92 hundredths is greater than 1/2, then we can logically conclude that the 92 hundredths has to also be greater than 2/7, because it's going to be greater than anything smaller than 1/2. All right, so this says, well, there's another way we can look at it. All right, well, let's look at it another way. We have 8 hundredths, or 8/10, excuse me, and 3/4, so that's 3/4. It says write 3/4 as a decimal, which is what I said would probably be easier for that one. All right, so when I have my 3/4, I'm going to change it into a decimal instead of coming up with a common denominator, making that a fraction. Then I know I'm just going to divide. Now, they've already showed you that there is a decimal and 2 zeros, but just remember, my numerator goes inside my division box because it's a decimal number. Then I add a decimal and bring it up, and then I will just add zeros until I don't need them anymore. I might have to go out 3, 4 decimal spaces. Usually in this level of 6th grade at the beginning of the year, I don't have to go out more than 4. So if you end up going out 5, 6, 7 multiple times, then we've probably messed up a step. Come and ask while you're working on it, and I'll figure out where your mistake is, and I'll help you find it. When I'm dividing, though, I start with my 30, because I've already raised my decimal and put it in place. 4 goes into 37 equal times, because 7 times 4 is 28. I subtract those and get 2 as a remainder. I bring down a decimal. Now, if it wasn't filled out for me, then I would have to remember, oh yeah, I have to add a decimal and bring it down. When I break down my decimal, then I have 4 and 20. I know that 4 times 5 is 20, so I'm going to have a 0 remainder. If I don't know that 4 times 5 is 20, then I would just take my handy dandy calculator and take 20 divided by 4 equals, and I would see it is indeed 5. So what we're saying is that 3/4 as a decimal is the same as 0.75 or 75 hundredths. Just a quick thought on that. If I'm talking about money, do I have a coin that 3 of them would make 4 whole, which would be $1? Well, 3/4 out of 4 is 75 cents. So that's just one of those quick ways that I can remember what a common fraction is changed into in a decimal. 3/4, because that's what the fourth says, is 75 cents. So I know it's 75 hundredths. When I've then changed that into a decimal, and this is a decimal, notice what they've done without even telling you why. If I put my decimal down here, this was 0.8, but now they have 0.80. So just as I said up here, I have to make sure that I have the same decimal spaces, because if I had 0.8 and 0.75 and I didn't, then I would have said, well, 0.8, 8 is smaller than 75. Not what we're talking about, because that would be whole numbers, and these are decimals. So I have to make sure that I have the same number of decimal spaces. That's why they've added that 0, because then I can see that 75 is actually less than 80. Therefore, my arrow is going to point to 3/4, because it's going to be the smallest value. All right, so now it says to use a number line. So it's just more and more things, but notice the math is never going to change. It's just different setups of math problems, but the work is still the same. All right, so now write each fraction as a decimal. Well, we can do that, but we have 4 numbers up there. And I have a number line that my 4 numbers have to go on. Well, one of the things that they've done is they've given you 2 decimals that are already on my number line. So they did have to work for you already on this problem. So now I just have to figure out what these 2 are as decimals and fit them down here in this space. So when I divide then, notice they've already added my decimal points and zeros telling me I have to go out 2 spaces. Then I want to make sure that I bring up my decimal before I divide so I don't forget it's a decimal. And 10 will go into 30. Well, it goes in 3 times. Why in the world do they have another 0 there then? Well, they have another 0 then because I see that there's 2 decimal spaces here, 2 decimal spaces here. So that indicates they all need to have 2 decimal spaces. So when I see that there's a 0 remainder, then I go over here and I notice what happens when I divide this. I end up with 2 times 4 is 8 with a remainder of 2. I bring down my 0, and 4 goes into 20 5 times, 2 decimal spaces also. So I do have to make sure that I add that 0 and have 2 decimal spaces for it. Once I've done that, then I have to figure out how my number line is set up. So if I notice I have 1, 2, 3, 4, and then I have an even number. 1, 2, 3, 4, I have an even number. So every 4th tick mark is going to be my even number in my decimal points. And my pattern goes 2, 4, 6, 8, 10, because 1.0 would be the 10. So that means then that how many would be my odd numbers? Well, if I went 4, 4, 4, 4 to get even, that means I'd have to go 2, 2, 2, 2 to get my odds, right? So every 2 would have to be my odd numbers. So this would be where my 0.1 is. So that means 2 after the 0.2 would have to be my 0.3. So that's where that one would go. And notice I didn't put the 0.30 because I have to put what the actual number was that I started with. So then that means if we just look at it, between the 4 and the 6, that'd be my 0.5. Well, if that's my 0.5, that might help me see where my other numbers go. This one's a 0.25 then. So if I have 0.2 and 0.3, it should make sense that between, if I put decimal spaces or zeros on my decimal spaces, 20 and 30, the 25 would come right in the middle. Or we could say if this is 2 and 3, this would be the same as 2.5. So that's going to go right in the middle of the 0.2 and the 0.3, which then with the number line shows me exactly what order they go in their original forms down below. So my 0.25 is actually what number when I changed it? Well, it's 1/4, so it has to be my smallest. And my 0.3 was what number before I changed it? Well, that was my 3/10, right? So that has to be my second number. And then my 2 decimals, they just stay in their normal form. I just make sure I put them in the same order that they're shown on the number line. So I have my 4500ths and my 9500ths. So everything has to go in order from least to greatest. And they're just using that number line to show you how they would actually lie in order. All right, so share and show. What's the point of share and show? For you to know how to do your homework assignments, right? So we have this thing called muscle memory, that the more I do something with my muscles, it provides a memory inside my brain. So when I am following along with the teacher and he's showing me exactly how to do the problems, I should have my pencil in my hand and I should be following along and taking my notes. All right, so on this one I have 3 sets of mixed numbers. My 3 sets of mixed numbers, but I know it's going from least to greatest, and I look at my whole numbers. I have a 3, a 3, and a 2, so I should automatically know which one is my smallest number this time. Well, that's going to be my 2, because 2 is always smaller than 3, so I know that I'm going to put 2 and 9/10 as my first number, and I don't have any work to show on that one. But now I got to show some work on my next 2, because they both have the whole number of 3. If they all had different whole numbers, that makes this much easier. But now I have to show some work. So they have a setup where I'm going to use my opposite denominators, right? Where I'm going to multiply by opposite denominators to get the same denominator, also known as a common denominator. I have a 6 here, so that means I have to go over to my opposite fraction and multiply by 6s. Notice I once again have to do it in top and bottom, so I don't change the value of the fraction I'm working with. And then over here I have 8s, so I have to take my 8 and I have to multiply over here by the opposite denominator, so top and bottom, so that I don't change the value. I'm only changing the digits. Then I just do my math. I multiply across, and when I multiply each of those, I should get the same denominator here as I have here, which allows me to compare my numerators. Well, 6 times 8 is 48, and 3 times 8 is 24. And then I come over here, 8 times 6 is 48. I did get my common denominator, so I know I'm good to compare my numerators. 5 times 6, well, I put 35, and that should be 30, so I apologize. It doesn't actually change how I compare them, but I did put the wrong answer up there, so I apologize. So I have 24, and I should have a 30. 24 is indeed smaller than a 30. It's smaller than a 35, which is the wrong answer, but it's still smaller than 30. So I know this one has to be my middle number, and therefore this one has to be my larger number. But I have to put them in their original form, not what I get when I do the math in order to compare. So I have my 3 and 3/6, which is my middle number, and my 3 and 5/8, which is my largest value. When I come down here then I have decimals and fractions. So once again, I went in through this division box in there because I do believe that dividing your fractions is going to be your easier way to solve your answers. My numerator goes inside my division box. My denominator is on the outside. So I have dividend and I have divisor. Now I have to add my decimal and bring it up because I can divide a small number by a large one. And then I add zeros until I come to the end and I don't have a remainder. Remember on decimals, I can never have just remainder standing there. I can't put an R inside of a decimal answer. I have to just keep adding zeros until I don't have a remainder. So I start with a 0. 12 does go into 43 times because 3 times 12 is 36, but I have a remainder. All right, so I'm going to bring down my 4. Well, that's what I just started with. Well, if I continue to divide and I have a 40, I once again have a 3. There's going to be a pattern there, isn't it? Because as I continue on, I'm going to get 3, 3, 3, 3. If you type that into your handy dandy calculator right now, 4 divided by 12 equals, you're going to get 0.33333. It's going to fill up your entire screen. So this is what we call a repeating number. Now we haven't taught repeating numbers, but they've just kind of thrown it in there. We could talk about rounding, but I don't want to add an extra lesson to this one. So we're just going to do a repeating number. Mathematically, the way we show a repeating number. And what that means is if you start dividing 4 by 12, and you continue forever, you would never stop. It goes on forever, because I always end up with the same remainder. So a repeating number, I put a little line over it. It just says that answer would always repeat. It's always going to be 0.3333 forever and all eternity. So when I look at 0.3 compared to the value of 0.8, so this is 3/10 repeated and 8/10, then I can see that my arrow should point indeed to the smallest number. So I know that my 3/10 repeating is smaller than 0.8. It does not matter that it repeats forever and ever and ever. I'm comparing the tenths column or the tenths place value, and 3 is indeed smaller than my 8. So my arrow has to point to the right. So I have 22 hundredths and 1/4. I'm going to divide once again. So when I divide, my top number goes inside the box, my bottom number goes on the outside of the box. I have 1 divided by 4. I can do that, just add my decimal and bring it up because I'm dealing with decimal numbers. Add a 0 and I begin to divide. Now this has 2 decimal spaces, and it's nice because if I think about, once again, money, 1 out of 4 coins, that would be a quarter. This fraction 1/4 is actually called a quarter, and the value of a quarter is 25 cents. So when I divide, I'm going to find out I end up with 2 decimal spaces also, so I'm going to have exactly what I need when I get a final answer. Well, 2 times 4 is 8, and I subtract as I get a remainder of 2. I add a 0 and I bring it down. I have 20, and 4 goes into 20 5 times, and 5 times 4 is 20, so I have a remainder of 0. So what I was talking about is when I see that that is 25 cents, 0.25, and this is 22 hundredths, 0.22, this is my smallest number. Because if I'm talking about money, 22 cents is smaller than 25 cents. So my arrow should point to the left. I'm going to divide 1/20 because, once again, I think it's easier. If you want to change this into a fraction and make sure that we have a common denominator, it takes some extra steps to do. There's nothing wrong with it. It's proper math. I'm just trying to find easier ways and quicker ways for you to be able to do your work. When I take my 20 on the outside and my 1 on the inside, then I'm going to add my decimal place. I'm going to bring it straight up and add a 0, and 20 goes into 10 how many times? Remember, that's 0, and I have to raise a 0 and put it up to hold that place value. Then I can add my next 0 and ask, well, how many times does 20 go into 100? And that's 5 times. So I have a decimal position that has 2 spaces. I have 5 hundredths compared to 6 hundredths. So I have 5 compared to 6, and 5 is my smallest number. So on this one, my arrow is going to point to the left. All right, so then we're going to go to 5, and that's my number line, and I have to put things in order from, and it tells me in the directions, least to greatest. So when I look at that, once again, I'm going 4 spaces between my numbers, right? So every 4, I have an even decimal number. This time, it just has the 1 in front of it. Doesn't change the process that it's going through. So that tells me that every 2 between the even numbers has to be my odd. So I have 0.1, I go 0.2, 1, 2, 0.3, 1, 2, 0.4, 1, 2, 0.5, 6, 7, 8, 9. That fits in perfectly. That helps me realize where these answers are going to have to go. When I look at this 1.25 then, I don't have 25 out there, right? Well, notice that that has 2 decimal spaces and these only have 1. So I have to realize that if I change those to where they have the zeros at the end, 2 decimal spaces and 2 decimal spaces, this is the same as saying 1.10, and these are saying the same thing as 1.20. If I know that those have 2 decimal spaces and this has 2 decimal spaces, that lets me see this is 25, and 25 has to go between the 20 and the 30. So I have 20 here and 30 here. That means this space in the middle has to be my 1.25, 1 and 25 hundredths. I could also look at it as saying that, well, this would be the same as saying 1.2 and a half. And this is just 1.2 and 1.3. So 1.2 and a half has to be in between 0.2 and 0.3. So I put a green asterisk here to mark where it was going to be, so that I'm going to look at asterisks then just to figure out where they're going to go. Now I have my ones, so I know I'm going to keep my ones as my whole numbers, but it's my fractions that I'm going to divide to figure out where they go on this number line. So I'm going to use blue and I'm going to use pink as asterisks just to put on my number line, so I don't have to write them real small over there. So I have my 4/5, I'm going to divide 4 by 5. I know it's a decimal answer, so I'm going to add my decimal and I'm going to bring it straight up. I'm going to add a 0, I'm going to divide. If I need another 0, I'll just simply add it. But 5 goes into 4 evenly, so I know I have 1.8. Well, 1.8 goes where on my line? 1 8/10 is found already marked over here, so I'm going to put my blue asterisk so I know where my answer is going to be. Then I have my 1/10, so I know my numerator goes inside my box as my dividend. My denominator of 10 is my divisor. I'm talking about decimals, so I add my decimal and I raise it straight up. So I have to add a 0, and 10 goes into 10 one time. So 1.1, we already showed that when I filled in what my tick marks were for every other two. 1.1, well, that's the same as the 1.10, because that 0 at the end doesn't change my value. So I know that my 1 1/10 has to be there. Therefore, my pink, my green, my blue asterisks tell me which ones go in which order. Now, I don't expect you to write with different colors as you're doing your assignments. Now, if it helps you to show your work, that's fine, but the only problem with you using different colors of ink means you're doing your math in ink, which means we can end up with some really sloppy work, because I hate it when you guys scratch and scribble and cross everything out if you mess up. Well, hopefully as you can see that makes it a little easier just showing you on a display on how it's being done, because my pink would go first. Original form of the number has to be written down as my answer. So I have 1 1/10. And then the green goes next, and that's between the 20 and 30. So the green was the 1 25/100, staying in its original form. And then the blue was the 1 4/5, where I divided 4 by 5. So my original form is 1 4/5. Those are in the correct order. All right, so what that means is we have some left in the on your own section. I want you to do these on your own, just like in the last video. So what I'm going to ask you to do is I'm going to ask you to pause. Now, if you would like, you can go question by question. You can go 6 and check the answer, 7 and check the answer, 8 and check the answer, or 10, excuse me, and then 11 and check the answer. Or you can do all 4 of those, 6, 7, 10, 11, and come back. I want to work all 4 of them and show exactly what you should have. I'm not going to show necessarily step by step, but I want to show you how you should have done your work, and then you can pause and check just to see in case you messed up. But if you got them correct, then you're good to go on. So pause the video now, and then come back to it once you have your work done. So hopefully you have worked out at least 6 or all 4 of them. So what you should have gotten on question 6 then is the answer of 0.6 first, or 6/10, followed by the 75/100, and then you should have had 4/5. So now, if you had, let's say, you know, the 4/5 was as a decimal, then you'd have to make sure that your answers are actually written as the original numbers. How did we get that work then? So as we're doing it, I'm going to divide my 4/5, make it a decimal in order so I can compare them. And then I also have to make sure that I have the same decimal spaces as I'm comparing. So in your work, what you should have had was 4 divided by 5, and you should have gotten 8/10 when you divided. Decimal spaces, there's 2 there, so that means I would have to add 2 or a 0 to the 6, so it has 2. And I'd have to add a 0 to the 8, so it has 2. What that tells me then, when I have them written down, is that these two, they have to switch positions, don't they? So when they switch positions, then that gets everything lined up, but I have to make sure that I put them back in original forms. As 6/10, 75/100 was what was given. The 8/10 is going to be my 4/5, or 4/5. All right, so pause the video if you didn't do number 7. If you did number 7 already, then you're good to go on. So your answers for number 7 should be in the order of 2/5, 7/15, and 1/2. Now I've worked this out 2 different ways for you. So some of you are going to like finding a common denominator. That is fine. I just feel like it has extra work to it. So I'm going to show you that way first, and then I'll show you the division, which I feel is easier, but either way is correct because there's more than one way to do a math problem as long as you're successful every single time. So coming up with a common denominator then, that means I have to find my least common multiple for 2, 5, and 15. So that's what I'm going to work down here. When I find my least common multiples, then I know, okay, then I'm going to have 15, I'm going to have 5, and I'm going to have 2. 2's covered up. I apologize for that. My little direction buttons are covering up. When I do my multiplication facts of 15 then, I'm going to have 15 and I'm going to have 30. I'm going to stop at 30 because I see that that ends with a 5 and a 0, and it has to be an even number because of the 2. When I do my multiplications of facts of 5, then I have 5, 10, 15, 20, 25, 30, and that is also going to work for the 15. It's up there, but it's also going to work for the even number. Because I know on even numbers that it has to end with an even number, 2, 4, 6, 8, 0. 2 will work with the 30. So 30 has to be my common denominator because it's my least common multiple for all three numbers. If I know I'm going to have a common denominator of 30, then I have to multiply the 2 by 15 to get the 30s. I have to multiply the 5s by 6s to get 30s. And I have to multiply the 15s by 2 to get 30. Notice I'm going to multiply numerators by the exact same numbers, so I don't change their value. I'm just going to change their digits so I can compare them. When I do my multiplication then, I get 15 over 30, 12 over 30, 14 over 30, and then I can put them in order. The 12 is the smallest, so I know my 2/5 is in the right place. That's followed by the 7/15 because 14 is smaller than 15, and then that 15 is the largest number. So they are right and in the order. But finding my least common multiple that works for my denominator and then multiplying by different numbers so I could get a common denominator, I think that becomes a little bit more difficult to where if I just divide, I really think that's a little easier for you to do to get to your answers. This one's going to be the first place, this one's going to be the second place, this one's going to be the third place, and I have to put them in the correct order. If I divide then, if I just take my numerator divided by my denominator, I directly will get 0.5. And when I divide 2/5, so my numerator divided by my denominator, I get 0.4. And then when I divide 7 by 15, this is where some of you might have gotten a little confused. Remember, we can have repeating numbers and we just show it with a little line. So when you type it into your calculator, you would have gotten 0.466666, and that's fine. We just put that little line over that repeating number like we did the 3 on the previous set. But then I have 2 decimal spaces. So I have to fill in with 0 so I can compare these two. Once I've done that then, I know that I have 50, I have 46, or 40 and 46. They're still going to go in the same order. 2/5 is still going to be smaller, 7/15 is still going to be my middle number, and 1/2 is still going to be my largest one. All right, so if you've done number 10, then you're ready for it, and if you haven't, then pause the video. The answer for number 10 should be an arrow, because that's what we're doing is comparing greater than and less than. It should point to the left, because we're going to see the 7/15 is indeed smaller than 7/10. When I do the work then, if you didn't get the right answer, I'm just going to use my common denominator. I'm going to multiply by opposite denominators. 15, so I'm going to multiply by 15s. Here's a 10, so you should have multiplied by 10s. Then you multiplied out and you got your answers. You should have 70 over 150. This gives you the 150 also, 15 times 10. But your numerator is 7 times 15, which is 105. With my common denominators, then you would compare, and 70 is indeed smaller. So your arrow should point to the left. So if you made a mistake, then here's the work that you should have. Find your mistake, and if you don't see it, then you can ask me a question, and I'll help you figure out where your error is. If you did number 11, then you're good to go on. If not, then pause the video and solve for number 11. But I once again would suggest that you divide, because what you should end up with is that these two are equal one to another. When I divide, I'm going to divide 1 by 8. And as I work through the process of dividing, then I'm going to see that I end up with 1, 2, and 5. So when you end up with your answers, if you didn't get these steps to get 125 thousandths, then check your work and make sure that you ended up with the correct answers. Maybe you subtracted wrong, or maybe you didn't go in enough for your number. You should end up with 125 thousandths on both sides, so you know that they are indeed equal to one another. All right, so then we're going to leave the rest of these as extra work in case you're struggling, you're not quite sure what to do. Come back and ask. It's a longer video because there's a lot of steps to it, but it's not different work than what we did previously. It's just adding this, comparing the greater than and less than, or it could be equal to, or putting them in order from least to greatest. As you're doing your work then, you have page 70, now you're going to do questions 2 through 15, and on page 80 you're going to do questions 1 through 6. So I've been working with people in the back of the room, so some people's videos are going to be finished earlier, but watch the entire video, take your notes, follow along, then work on your homework. If you're still not sure, come back and ask, and we'll work on some of these extra practice problems so I know that you understand what you're doing before you get into your assignment.